Section 2.2, more on functions and their graphs. We are going to learn a lot of little topics in this section. All of these relate to sections we do later, so it's going to feel very disjointed, but we do eventually use everything in here. First thing we have is the definition of a difference quotient. What this is f of x plus h, so we're going to have to plug in x plus h, and then we have f of x, that's given to us, divided by h. Now, if you took calculus, you will recognize this as part of the definition, one of the two definitions of a derivative, okay? But that's not important right now. If it looks important to, familiar to you, that's probably why. Okay, so let's find and simplify the difference quotient for the given functions. So right here, I'm given f of x equals 7x. So this piece is going to go right here. Now I also need to calculate f of x plus h. So this means I have the 7 times x plus h, which is 7x plus 7h. Okay, so let's figure out what we have here. I'm going to take f of x plus h, which is 7x plus 7h. I'm going to put this in parentheses for right now, just so it's easier to figure out what's going on. So this is this piece, minus f of x, and f of x is 7x. And then divide this by h. Now, what is going to happen on these problems, no matter how complicated your function is, and obviously we're going to get to one that's more complicated, is once you do this arithmetic in the top, every term that does not have an h in it will cancel out. So what I have here is 7x plus 7h minus 7x divided by h. And here I have 7x minus 7x, so that goes away. So I have simply 7h over h, and we can cancel out those h's. And the difference quotient is exactly 7. If you took calculus, the derivative of this is 7. Okay, now let's try this for f of x is equal to 3x squared plus x plus 5. The first thing we have to do is to calculate f of x plus h. And this will equal 3 times x plus h squared plus x plus h plus 5. Okay, now this is equal to, I need to square this out, 3 times x squared plus 2xh plus h squared. This is basically the definition of how to square a binomial, but instead of a and b, we have x and h. Plus x plus h plus 5. Now let's distribute the 3. 3x squared plus 6xh plus 3h squared plus x plus h plus 5. Now, do I have any like terms in here? The answer is probably not. No, I don't. Okay, so now let's find the difference quotient. And we're going to take this minus this and then divide it by h. So I have 3x squared plus 6xh plus 3h squared plus x plus h plus 5 minus this 3x squared plus x plus 5. And all of this is over h. Now on your paper, if you would like just to do these calculations and then after you've simplified the top, put it over h, feel free to. If I weren't trying to teach it, that's exactly what I would do. Now, look right here. We have this -1 that we need to distribute. And there's nothing to distribute here. So I get 3x squared plus 6xh plus 3h squared plus x plus h plus 5 minus 3x squared minus x minus 5, and this is all over h. All right, like I said on the original problem, this problem up here, everything that does not have an h in it will cancel out. So I have 3x squared minus 3x squared, gone. X minus x is gone. 5 minus 5 is gone. Now, technically what I have here, I don't have a whole lot of space here, but technically what I do is I now split this up into multiple problems, and so I can simplify them. I have 6xh over h. That's, the h doesn't equal this. This whole thing equals this. 6xh divided by h plus 3h squared over h plus h over h. Now, reduce each of these. My h's cancel here. One of those is gone, and then this is 1. So my answer, the difference quotient here, is 6x plus 3h plus 1. And that's your answer. Okay, now let's look at a new topic, piecewise defined functions. And we talked a little bit about this in the last section, okay? These are functions that are literally defined in pieces, and we're going to have to decide which piece to use based on the conditions. So let's just evaluate the following piecewise defined functions at the given point. Here's our function. F of x is equal to 6x minus 1 if the number we're plugging in is less than 0. Our function is equal to 7x plus 3 if the x we're plugging in is greater than or equal to 0. Okay, so let's do f of -3. So -3, figure out which of these two conditions it belongs to. -3 is smaller than 0, so I'm going to be plugging in here, to this top one. So this is 6 times -3 minus 1, which is -18 minus 1. Your answer is -19. We do not plug it into each one. It's going to apply to one line in the function. This could have 4 or 5 pieces to it, but you always look at what it is you're trying to plug in and then figure out which piece it needs to go to. Okay, so let's plug in f of 0. Which of these belongs to 0? Well, we're not allowed to equal 0 in this one, but we are allowed to equal 0 here. So we're going to use the bottom line. This is 7 times 0 plus 3. That's just 0. So your answer is 3. Okay, now let's calculate f of 4. 4 is bigger than 0, so we use the second line. This is 7 times 4 plus 3, which is 28 plus 3, and your answer is 31. Okay, now let's do another one of these. Our function g of x is defined to be, sorry, dropped another piece of paper, x plus 5 if the x value we want to plug in is bigger than or equal to -5. But if the number we want to plug in is smaller than -5, we have to use this line. Okay, so let's find g of 0. Where does 0 fall? Well, 0 is bigger than -5, right? So I'm going to plug it in here. This is 0 plus 5, and your answer is 5. Let's find g of -6. Which line does this belong to? Well, is -6 bigger than -5? No, it's smaller. So I need to plug into the second line. So this is -6 plus 5, which is -1 which is positive 1. Now let's calculate g of negative 5. Here we are allowed to equal negative 5, so this is the one I plug into. I'm not allowed to equal negative 5 here, so I plug into the top one, and I get negative 5 plus 5, which gives me 0.